Welcome students. Today we will solve fourth problem on kinematics of particles. So let us start today's lecture. So we are given this problem. So let us read the statement. A ball is tossed with a velocity of 10 meter per second directed vertically upward from a window located 20 meter above the ground. Knowing that the acceleration of the ball is constant and equal to 9.81 meter per second square downward, determine A part, the velocity v and elevation y of the ball above the ground at any time t. In the B part, we have to find the highest elevation reached by the ball and the corresponding value of t. Then we have to find the time when the ball will hit the ground and the corresponding velocity. So we are given this situation. A ball is thrown from the window in our direction with a velocity of 10 meter per second, and that window is located at 20 meter from the ground, and we are asked to find velocity and elevation y of the ball above the ground at any time t. So we are given initial velocity of the ball, that is 10 meter per second. We are given initial distance also of the ball, that is 20 meters from the ground, and we are given that ball is under acceleration of minus 9.81 meter per second square. This is given in the question. So in the A part, we have to find the velocity v and elevation y of the ball above the ground at any time t. And we know this is a case of uniformly accelerated motion, because when we will throw the ball in our direction, it will be under the effect of gravity. And we know for uniformly accelerated motion, three equations are applicable. That is v equal to u plus at, s is equal to ut plus half at square, v square minus u square is equal to 2as. So for A part, equation of velocity for this ball at any time t will be given by v equal to u plus at. And equation for its elevation, that is the distance traveled by the ball in y direction, that will be equal to s is equal to ut plus half at square. Over here we are replacing s with y because distance is traveled along y direction, and in this case initial distance of the ball is also given because ball is thrown from a window which is 20 meters from the ground. So we have added y naught in this equation, that is the initial distance of the ball from the ground. So this is the answer to the first part, that is equation of velocity and elevation y of the ball at any time t. Now after that we have to find the highest elevation reached by the ball and the corresponding value of t in the B part. Now for this B part we have to apply the logic. We have to find the highest elevation reached by the ball. And we know the highest elevation of the ball will be reached when final velocity of the ball will become 0. So in B part we will apply the logic that for maximum height attained by the ball, the velocity or the final velocity of the ball at that height will be equal to 0, because at that point velocity of the ball will become 0, and for that point the distance traveled by the ball is maximum. Over here we have two equations, and for B part we have applied logic that final velocity of the ball will be 0 for the maximum height attained, and final velocity is available only in this equation. So let us see what we can find from this equation. So when we will put final velocity equal to 0 in this equation, we will get value of t, because we know initial velocity of the ball, that is 10 meter per second. We know acceleration of the ball, that is minus 9.81. and we will get t from equation number 1. So that is the time which ball will take to reach the maximum height. So let us find that value. So we'll put v equal to 0 in equation 1, and we'll put u equal to 10 and a equal to minus 9.81, and we'll get time equal to 1.012 seconds. Means after this time ball will reach to its maximum height. Now maximum height over here is represented as y, the distance traveled by the ball in y direction. So now we'll apply the second equation, and in that equation we know the value of y naught. So y naught is 20 meters and initial velocity is minus 9.81. Time we have calculated, and a we know, that is minus 9.81. So when we'll put these values, we will get value of y. So this value we have answered from the ground. So this value tells us that maximum height attained by the ball from the ground is 25.1 meters, because we have added initial distance also in this equation. So we have calculated B part also. Now we will find C part. So let us see what is given to us in the C part. So we have to find the time when the ball will hit the ground and corresponding velocity. Means we have to find at what time ball will hit the ground and what will be the velocity of the ball at that time. So we know about these two equations. We have calculated these two equations in A part. So these two equations will help for C part also. So for C part, we will apply the second equation, because in this C part we have to find the time when the ball will hit the ground. So we have thrown the ball from the window. So motion will be, ball will first go in our direction, it will attain its maximum height, and from that point ball will travel in downward direction, finally it will hit the ground. It means when the ball will hit the ground, the distance of the ball from the ground will be 0. Over here in this equation we have considered y as the distance of the ball from the ground. So when ball will hit the ground, it means y will become 0. So this logic we will apply. So put the value of y equal to 0 in this equation, and y naught as 20 meters, u as 10 meter per second, a as minus 9.81. Then we will get a quadratic equation in terms of t. So in this quadratic equation we have a as minus 4.905, b as 10 and c as 20. So we will apply the formula of quadratic equation, that is t equal to minus b plus minus b square minus 4ac. Take the under root of this part, divided by 2a. So we'll put the values of these in this formula and we will get the value of time. That is the answer to the first part of C part. That is, find the time when the ball will hit the ground. So at 3.2 seconds, ball will hit the ground. So what logic we have applied? That when ball will hit the ground, its distance from the ground will be 0. So we have put value of y equal to 0. Now next we have to find that at what velocity it will hit the ground. Now that will be the final velocity. So final velocity we have to find. Initial velocity we know, that is 10 meter per second. Acceleration we know, that is minus 9.81. And time we have already calculated, that is 3.28. So we'll put these values in equation 1 and we will get the final velocity as minus 22.2 meter per second. So minus means it is in downward direction. So I hope this numerical is clear to you. Thank you very much.